Okay, this is another example uh, related to probability trees, so we actually won't be drawing the tree for this question. You'll see similar questions in the worksheet you're going to get. Okay, the diagram shows a model railway track. At each of the junctions P, Q and R, the probability of a train going straight ahead is 2/3 and the probability of it branching to the right is 1/3. So the first thing we do is look at our track and then we label the probabilities onto the track. So the train will start at A here and then it must go to P. So the probability of it going to P is 1. So we can actually ignore that probability because we have to go to P. But once you get to P, you can either go straight, and the chance of going straight is 2/3, and then the probability of it going to the right is 1/3. So we label it that way. So if you go to straight, you'll go straight to B. Okay. So, but if you turn, you'll turn and then you'll bend here. This is not a junction. Then we'll go straight to Q. When you get to Q, we can either go straight, which is 2/3, or we can turn right, which is 1/3. So if we go to R, we can either go straight, which is 2/3, or then we can turn, which is 1/3. Okay, so once you've labeled the diagram, we can calculate some probabilities. So what's the probability that it will get to C, point C? C is here. Now the important thing of these questions, the train can't go backwards. So you can't go this way and then go backwards like that. We're not allowed to go backwards in the question. Okay, otherwise it makes things very complicated. So to get to C, how can we get to C? We'll use a highlighter. So to get to C, there's actually only one way you can do that. So 1/3 here, 2/3, 2/3. That's the only way you can get to C. You're not allowed to go backwards. Okay, so the chance then to get to C is, what are your probabilities? We've got 1/3, multiply, not add, otherwise you'll end up with more than 1. And your chance can't be more than 1. So 1/3 times 2/3 times 2/3 here. So that's 4 on 27. So your chance of getting to C is 4 on 27. Okay, so let's clear the shading, the highlight, because we want to go to D now. Okay, so how are we going to get to D then? How can we do that? Use the shader. Let's use green now. So to get to D, which is here, how are we going to do that? And we can't go backwards. So we can go this way, 1/3, 2/3, 1/3, D. So let's write that down. So 1/3 times 2/3 times 1/3 to get to D. So that's 2 on 27. But there's more than one way. That's one way, but what's the other way? Let's clean your highlight. So we went through R, but now we can go another way. We can go 1/3, 1/3, that way. So that's another way that we can get to D. So then that is 1/3 here and 1/3 here to D. So 1/3 times 1/3, which is 1 on 9. Okay, so there are two ways. What we do then, the two ways are added. So we can either go this way, 2 on 27, or is addition in probability, or 19 that way. So that's 2 on 27 plus 3 on 27 if you convert that. So 5 on 27. So your chance of getting to D through 2 ways is 5 on 27. And you do that question in the sheet the same way that I've just done it here. Okay, I'll give you some more examples in a minute.